Okay, in this problem we have 10 grams of copper sulfate that is dissolved into 500 mils of sodium phosphate solution, and we're going to assume that the volume of the solution does not change. Now the first thing we need to do is nomenclature and identify what are the ions present. So copper, and what is the formula? So copper 2 sulfate has a copper plus 2 cation, and it has a sulfate SO4 minus 2 anion. Since the charges are equal, the formula would be CuSO4. I'm going to put a parenthesis here. And now we're going to look at the second reactant, and I'm going to put a line in front of each of these for the stoichiometric coefficient. And we have sodium, which we know is an Na+, and we have phosphate, which we know is a PO4 minus 3. So the charges are different. And remember from the principle of charge neutrality that if I take the number of these being the charge of this and the number of these being the charge of this, I would have 3 positive ones for every 1 minus 3, and that gives me a neutral formula. Now, for the double displacement reaction that we have, we swap partners. So we make copper phosphate. So for this to be neutral, we'll need 3 of the plus 2's, which is a positive 6, and 2 of the minus 3's, which is a negative 6. So we form Cu3PO4 2, and we put a parenthesis here for the phase, plus we form sodium sulfate, Na2SO4, and we put a parenthesis there, but I should have put a line in front. That's why I tell you to put a line in front, so that you remember to have room for the stoichiometric coefficient. And hopefully we don't run off the board. Now that we've done this, we use our solubility rules, okay? I think it was rule 2b. This would be AQ, okay? Now realize that we dropped the solid into the liquid and it dissolved. All salts of sodium are AQ, so this is AQ. If we go to our rules, in rule 3 we see that this is a solid. So we've given an S, and S doesn't stand for soluble, it stands for solid, and this is an AQ. So now we recognize that we have created a salt, and we could quickly look at the net ionic equation for that, which would require 3 coppers and 2 phosphates. But now what we want to do is balance the equation. Now I look at this, and the sodium has a 3 sodium here and a 2 there. And for double displacement reactions, what we do is we balance the ions. So I'm going to first balance sodium because it's the most complicated, okay? So 2 of sodium phosphates has 6 sodiums, and 3 sodium sulfates has 6 sodiums. Now I can choose either one. I'll choose the sulfate. I have 3 sulfates, so what I do now is I start balancing the counter ion. So I have 3 sulfates here, so I come over here, and I have 3 sulfates here. I have 3 coppers here, 3 coppers here, 2 phosphates here, 2 phosphates here, and I'm back to the sodium, and this is a balanced equation.